All right. So today we'll do the regular lecture. This is a real introduction to Linux. So you guys need to start with the little bit the broad scope of Linux operating systems, and then we can dive into a specific operating systems, which is a Debian distributions. You may be able to see it, and I'm going to give you all the guidelines, the way that many of you asked the questions about Raspberry Pi, uh, and I uh, have written there. Uh, it will be provided by the universities. Actually, provided by two programs: computer science program and cybersecurity programs. Most of you guys are from cybersecurity, and I know quite a few also from computer science. So two programs supports the purchase of the Raspberry Pi. And not all of you heard of the Raspberry Pi, but some. Abdul, have you heard of Raspberry Pi? Oh. So Raspberry Pi, let me show you if I can show this to you guys. This is a Raspberry Pi. Okay. So you guys may receive this. Actually, you need to receive this by next week. Those of you guys, you are still come here with me, so I am going to bring it. Okay. So come, make sure that you need to come next week. If you don't come next week, if you don't start with the real Raspberry Pi, then you're already quite behind the mainstream. Okay. So please make sure you should be here next week, even if you are busy. Many of our students are busy. Okay. So I have some of the camera here. This is the Raspberry Pi. So you will receive this. As you may see here, I have extra monitor and extra mouse and extra keyboard, wearable keyboard. This is not really expensive wearable. This is many of our students from, for example, the previous class, they love this. Has nothing to do with me, okay? I just purchased this. But anyway, this kind of, you can roll it up and then put it on your backpack to carry. This is the way that I carry. Monitor, this is a small monitor that you could have. You can see some of the images. This is for the Raspberry Pi. I'm trying to give you broad aspects, okay? And also I want to motivate you. This is the whole purpose of today's class. Last week you had the snow. Did you enjoy snows? Still enjoy? Struggles? Abdul, you, what happened to you? Oh, only that? Anybody has any the physical harms, damages? Oh, that's good. All right. So, all right. Many of the other things that we need to discuss in addition to the real technical aspects. So I'm going to cover the technical stuff first. This is our lecture today. So this is available, right? So you can I do not like always full screen because it prevents all other simultaneous possibilities. Okay, so we'll do the basic aspects of the Linux. So what is a Linux? Well, before we talk about the Linux, there is a more formal operating systems developed further earlier than Windows and has been established technically, theoretically, very well. And still, this Unix is the most powerful and reliable and secured operating systems. Almost all Fortune 500 companies, corporates, are running their systems on the Unix. Okay, Unix. Not Windows, of course. Not Windows. Unix. Not even Linux, but sometimes Linux. Okay? If they have enough budgets, then Unix. If they do not have enough budget, like academia or small corporate, small startups, then they use the Linux. Our university, Mercy University, most of the systems running on Windows, not the Linux, not Unix. Our cybersecurity web server, currently that is shut down because of some of the issue, but had been running over Linux. Why it was shut down? The running our own systems requires lots of the resources, including humans. Okay, technicians needs to stay 24/7. Guess what? That's impossible, right? Who did that? I did that by myself. All right. So I cannot do that anymore. Not because of myself, but system itself dying. We used that server. We have a server shelf, the full height of a silo. There are lots of network equipments and also computer servers running. Has been over 10 years ago, for 10 years. So it is dying. But anyway, so Unix is basically multi-task, multi-user operating systems. It has developed in 1969 at the AT&T Bell Labs. Have you heard of the most? It was, previously famous the research lab called Bell Lab, but not anymore, right? Bell Lab is decaying. I think after Bell Lab, there's some of the other things, Lucent technologies. But anyway, Bell systems, Bell companies, including Baby Bells. It was about like 30 years ago or earlier, when I was young, right? So Bell Lab was the high end, the leading technical companies at that time. Many of the Bell Labs are located in New Jersey State. So Bell Lab, the researchers in Bell Lab developed, like 1969, and then they developed C also. So Unix and C runs together. When I was a student, when I took the Linux class and C class, luckily the instructor was the developer when he was in Bell Lab. So I was grateful at the time. And after this Linux developed, and then there's a similar variants like System 5, Solaris. Solaris is still the one of the best operating systems. The name Solaris is not only operating systems, but it is a real hardware. So which company runs and owns Solaris? Solaris was developed by Sun Microsystems. See, this is Sun. Not anymore available. Sun Microsystems. This was really big. I like this company, but this company was acquired by Oracle. Have you guys heard of Oracle? Oracle is now leading companies, right? They are doing lots of AI investments. But Sun Microsystems was, they developed many good products. Some of them you may heard. Java. Have you heard of Java? Programming. Right? Cool. It was developed by this company, Sun Microsystems. MySQL. Sun Microsystems, Java and MySQL are free. Most of the software they developed are free. This company. It's not like Microsoft. But this company was acquired by Oracle. This company was not only developed Java and MySQL, they developed operating systems called Solaris, and also hardware, Solaris. This is one of the best operating systems. Before we had the Linux, before we had the Windows systems, even small academia, small universities, colleges must purchase Solaris. Otherwise, there is no other systems. What is the minimum price of Solaris? 10,000. So it's not affordable. No students cannot buy. Even university, for example, must purchase this at least maybe 50 or 100 regularly every 5 years. 5 years, then they have to replace with the new versions and new versions. But thank God, because we have Windows, we have Linux systems. So Linux operating systems may be able to run on Windows and also Mac. And then there is a other. Yeah, actually, this is a Sun OS. This is a Sun Microsystems, right? That is, Sun OS was evolved to Solaris. So Solaris is the later versions. And then BSD, there are many BSDs. There is a Berkeley University of California, Berkeley. their software distributions. So they developed the Berkeley versions and the Bell Lab versions. All right. Then we had the Linux. Linux was developed in 1991 by graduate students in Finland. So this is a student products, like, for example, Swift. Have you heard of Swift? The language called Swift. That is a language that you can develop iPhone applications. There is a next version of Objective-C, which is a later version of C. Okay, developed by students. Similarly, Python. It's not really inventor of Python. Is not really student, but just the person just graduated when he was working in some company, right, in Europe. Just like that. So he developed this in 1991. I still remember when I was a student. And then initially, the Linux source code was released. Okay, that is the strength of this Linux. Initially, they developed small capabilities of Unix operating systems. And he released the source codes. So many students downloaded it, and they added more capabilities. So many students add their gifts on that. So Linux operating systems becomes stronger, and bigger, and used by more students. While they were students using Linux, they would like to continue to use Linux operating systems, even if they are working at the real work, right? Therefore, Linux is now not only the university operating systems, but most other, even big Fortune 500 companies, their production systems are running on Solaris, for example. But most of the developers are running on the Linux because the Linux is free, right? Even if a Fortune 500, why they need to waste their money, right? If they have, for example, 10,000 employees working on the Unix, then they can, daily basis, they can use the Linux. When the development is complete and to release as a production systems, then they can put it on the Unix. So Linux and Unix are not much different now. Okay. So it is a part of GNU. This is also the academia, the associations started at MIT, and then is now spinned off. So Linux kernel is released. It was organized by GNU. What is GNU? GNU means GNU is not Unix. What is GNU? GNU is not Unix. Okay. This type of acronyms, ironically, are available in many cases of computer science. For example, PHP, then PHP is, I think, hypertext process or something like that. So what is a PHP? PHP is a hypertext process. Okay, so that is a Linux. So what is this? So most cloud servers now runs Linux. Okay. Many of my courses also rely on the cloud. Personally, I use Google Cloud because not because Google Cloud is the best, but because it is cheaper than, for example, Amazon. I guess Amazon is the best technically and also service-wise, maintenance-wise. So majority of the internet running on Linux, and your smartphones running on Linux, iPhone, Android phones, they're all running on top of a Linux. So once you know the Linux, then you may be able to see almost all the Internet of Things. Okay. You can break in the systems because it runs on the Linux operating systems. All the electronic devices, home appliance, if it is called smart something, smart refrigerator, smart washer, then it runs on the Linux. Why? Because it has in it this Raspberry Pi. Okay, this Raspberry Pi is big, right? But there is this smaller ones, like a finger. This type of this narrow, small things. You can develop something on this Raspberry Pi, and then you can deploy it. That small, like a finger size. We call that a microcontroller. This microcontroller may be able to handle very powerfully everything about your smart refrigerator, for example. Okay. And cybersecurity tools, most of the cybersecurity tools runs on Linux, right? Anybody heard of any the specific version of Linux that cybersecurity professionals or students needs to learn? What is the name of that Linux? You're not at that level yet? It is called the Kali Linux. In our class, we do not have anybody called the Kali, right? There's no Kali. Okay, Kali Linux. If you download the Kali Linux, can also install on your Raspberry Pi. Then that small Raspberry Pi can, for example, attack or defend in cyberspace. Some other courses may be able to use it, not only running on your laptop, but small microcontrollers can do. Sometimes more powerful. Supercomputers. You can build the supercomputers using Linux. Each Linux run on that Raspberry Pi. You can pile up that Raspberry Pi, that small ones, hundreds of Raspberry Pis. Then it'll be a supercomputer. We did that a few years ago. We purchased about 50 Raspberry Pis. But the problem is Raspberry Pi, it evolves. This Raspberry Pi is, so who developed this Raspberry Pi? What is the manufacturer of this Raspberry Pi? That is not American products. This is UK products. Fortunately, unfortunately. Okay, UK products. All right. So we can make the supercomputers of Linux runs on Raspberry Pi. So most of the embedded systems run on Linux. That can run on Linux is operating systems. Hardware device is Raspberry Pi. It is not almost possible. You can run any embedded systems using Windows operating systems, because the Windows operating systems has a lot of messes in it, right? And also size is so big, and the capabilities is so small, so we cannot. Linux emphasis. It is a transparent. You may be able to see that. And securities, automations, efficiency, and more. You may learn that a little later. Not later today, but later in this semester. Some of the Linux demo that I would like to give, but only I can do it if I can, but it cannot be recorded. Why? Because we have a router. Router currently shut down, so I need to talk to IT. I do not know why it shut down. There's another technical barrier I would like to explain to you. If I want to show that the Raspberry Pi terminal, this is a Raspberry Pi terminals, right? On this laptop Windows, these laptop terminals, then there is something they need to talk, right? That Raspberry needs to talk to my laptop. How can they talk? They need to talk through routing, right? Router. Can they use our enterprise router? No, they cannot, right? Enterprise router means, if you see here, this is my router, right? This is currently Mavericks Wi-Fi, right? So Mavericks Wi-Fi router. Mavericks Wi-Fi router is the enterprise router. That router is routing the laptop of the students whose major is not necessarily cybersecurity, but any major. So university doesn't allow our Raspberry traffic goes into Wi-Fi router. Right there, it doesn't go out to the internet, but coming back to the internal is a loophole, okay? It reaches to the router and coming back inside that subnetwork. My laptop is inside that router subnetwork. My Raspberry Pi also runs on that subnetwork. The network traffic goes into that router and then return back to the inside. If it allows, then attack is so simple, right? So usually enterprise Wi-Fi router does not allow that loop back signals. So most of universities, then we need to install other specific independent router. That's we usually set up in Westchester campus and also here Manhattan campus. So from time to time, the router shut down. Some reason, right? You may have that also, right? it needs to reset. But I do not have that authorities. So I cannot connect this. But by next week, it'll be done. But I'm going to explain this. Linux can do, this is a motivating examples. So we may be able to see Linux is alive by giving this command. PS stands for process status. That is a Linux command. So that you can see the list of a process. What is a process? Oh, okay. He mentioned the service and then applications. Not only application, but systems as well. Some of the programs. As a developer, you develop a program, right? One single program. I want you to recall, for example, Python program. One file, that is an application, that is a program. In the developer's point of view, that is called the program, right? Java program, Python program. When that program runs on your computer, then it is called a process. The same thing can be called differently, depending on where that object is and how it is behaviors. And sometimes it is called a service if it runs on a server, right? So there's a process. For Raspberry Pi, for example, on this demo that I would like to show, you don't do anything. For example, okay, you turn it on, you don't do anything, but you may be able to see hundreds of processes running. What does that mean? Linux is alive. Linux is alive. While you are idling, Unix is doing something, not something, everything that it needs to be, right? Another thing, Linux security is real. Real means it sometimes works, sometimes not working. No, it is real. Therefore, as a cybersecurity professionals, you need to, whatever that you need to do, you need to work on Linux, okay? That I want to show that to you. For example, Linux is a multi-user. So Linux, you can see multiple other users in Linux. Not only you as a owner, but anyone. If you grant someone to access your Raspberry Pi, anybody can do it. Can be handled on this file /etc/shadow. I would like to show to you not only /etc/shadow, but there is another file. The name of that file, if you heard, then you can see, oh, that is what it is, right? It's called /etc/password. Okay, that is a file. So if you see that a file name, PSSSWD, then you can see the list of the users, and it has all kinds of users' identity there, including password. The way that I explained now was that way back in about 15 or 20 years ago. Since then, Linux and Unix Solaris operating systems has changed. That password, pull real password from password file to add into another file called shadow. Okay. Namely shadow, therefore, it runs behind. It is very, very important. But up front, you don't see it. So it is called the shadow. So if you see the shadow, then you can see the password. Of course, it is all encrypted, right? You cannot read it, but password there. This password cannot be accessed by anyone. Only the system administrator can do. That's what I want to show this to you. /etc/password. This is a file name. passwd. So in Linux operating systems, if we say password, then actually it is written passwd. This file can be accessed, but this file cannot be. That you should understand. Not today. Okay? By the end of this semester, you should understand why /etc/password file is accessed by anyone, but no one can access shadow file. That's a security issue. Abdul, you want to give us some comments? No? Do you have some experience on this? Not yet? Okay. Anybody know that? Can you explain? On the other hand, why the then password is released to anybody? Then why don't we protect the password file itself? Why should we create another file called the shadow, and shadow is not accessed, but password file is accessed?
Shadow file contains the string of the password. So let's say the password, maybe 256 string, and then goes in there. So it will be difficult for someone to break.
All right. Thank you. I think he knows 75%. The rest of 25%, for example. If I enter my password, try to access, then should I go to shadow or should not? If myself cannot go to shadow, how can then my password can be verified? Okay. But actually, so that is some of the process, okay? When I go in, log in, then there's a session. It's my session. It's called the session, okay? My session. Me, that is my process, owned by me. And that is my privileges there. There's a string attached to me. Okay? It's not the root privileges. It is my privileges. My privilege is there. So my process goes to password. Look at my file there. It goes to shadow file and look at my file there, my password there. Unless otherwise, my login may not be processed. That is a little bit of a security issues. If when I log in, at that point, if my process is nothing but the super user process, then I can grab that super user privileges, then I have all the privileges on the system. So that is a hack. Hackers can do. To prevent that, when I log in, it's not really super user's privileges. It's my own privileges. So I don't do any further than the privileges that is granted to me. I cannot do any overpowered. So I cannot go to password file. I cannot go to shadow files. Without going to shadow files, I cannot verify myself. Hey, this is my password. My password is validated and verified. It is impossible. So a little bit of a trick is there. So there is a context switch somehow from my privileges to super user privileges. That's short time period. Then super user goes into shadow and see my entered password is the same as the password saved in the shadow files. And then context switch back to me, my privileges. If you are lucky, if you are a strong hacker, on that point, if you interrupt it, then that will be your privileges. Whose privileges is your privilege? Super user privilege, it will be your privileges. That is what hackers can do. To prevent that, then password file is open to everybody. Shadow file is closed from everybody, except the super user. So super user is that much important. Many cases, if you subscribe to, for example, cloud, then they said, you have all the privileges, that's your systems. For example, our Google Cloud teams cannot do anything, so don't worry about it. Is that really true? No, it is not really true, right? They can do anything they want to do, right? But they don't do that. Can we manipulate it? Anything that you can do on computer, then you can do. Anything, okay? Anything. So that is what happens. Part 3, automation power. That is also possible. That's what I want to do, but as you can see here, some of the language, there is a for loop, right? You know this. In this. So far here, then this looks similar to Python, right? And then there's some symbol like this. And there's some file name. And there is a, looks like done. So one single statement may be able to do so many things in it. And there is a delimiter, semicolon. Looks like this is one statement and another statement. and there is another statement also here, right? So combining all of this, one single line, so many things can be done automatically in one single line. That is a Linux. Okay? So Linux is powerful. This motivates you. I'm not teaching you this, okay? I want you to expect such things in the near future. This is tables compares between Linux and Unix. There is a shell called shell. So the shell that we are using is bash shell. Bash means born again shell. Bash shell. You may be able to see that is a bash shell. When you install your Linux operating systems on your Raspberry Pi. And difference between Unix and Linux. Unix is copyrighted. Linux, that is a free software. That's what we are using. Okay. It is free. It doesn't mean that it is less powerful. It's still very powerful. Why it is still free? Because it was invented by a student, right? Unix is a command-based operating systems. Yes, same as Linux. But Linux has some of the graphical user interface, some others, but we are working on command. In this class, we stick to command-based. What does that mean? Command-based means. Command-based. There's a language-based, okay? So you type it, not click it. Very small viruses, all result. It's not like a Windows. Windows is millions, billions of viruses. File systems are well supported. So ext, ext3, you don't need to worry about this. But so this is the distributions of Linux. So many variants, right? So they're all similar. So ours is very similar to this Red Hat, and actually that is real direct of Debian. Difference between Debian and Red Hat is Debian is really completely free. Red Hat company runs, so you can get some technical support from Red Hat by subscribing. You do not need to, right? But there is a company managing the Linux. If you want to rely on that company, then you can do Red Hat. And then there is a same operating systems that run on Red Hat But we can do separately. Same version of operating systems run on a Red Hat. But if you want to run separately, then that is called the CentOS. That is also something that we can do, right? But they're all the Linux. If you know one, then you know others. Definitely. Okay. There's no difference. So where are we going? We are going here. Debians. We are not working on Debian itself because we are working on the Raspberry Pi. By the way, some students may ask, oh, why don't we use, for example, some of the VirtualBox. We can set up VirtualBox, but there's a problem. Somebody has a MacBook, someone has a Windows, then they can run different VirtualBox. The operating systems may be able to differently. Then lots of dialects, lots of it's almost impossible to all the class cannot be on the exact same page. So each one has a different page. Okay, then there's a big problem. Therefore, hey, let's make it one page. Let's working on one hardware, same hardware. Then there's a Raspberry Pi. Same operating systems, so-called the Raspberry Pi OS. So what is the Raspberry Pi OS? Raspberry Pi OS is one of the Debians, which is most popular. So that is Raspberry Pi. Raspberry Pi OS. So that is operating systems. So when you know this Raspberry Pi OS, you can say, hey, I know Debian. Or you can even say, hey, I know Linux. Because there is no big difference at all. Little bit of services may be different. One service may be available in Debian, the other may not be available on Red Hat, depending upon use. But that services can be done in very, very simple way, and that is usually a graphical user interface, like the way that you install applications on your Windows systems. You simply click it and it install it and you simply use it. That much difference. But core 99% remains the same. Somebody also heard of Ubuntu, right? Ubuntu is also part of this Debians. As I said, CentOS is here. Red Hat, that is if you have enough budget in your company, so that you want to make sure your system runs more robust way, rather than hiring more employees and give them privileges, but all the technical support may be from Red Hat companies, reliable company, reliable team, then you can use Red Hat operating systems. But if you want to do, hey, we want to partially on our own way, then you can do CentOS. the language, the command that you can use CentOS, same as Raspberry Pi, same as Ubuntu. They're all the same. Okay, no difference. So which Linux distribution is better? Personally, Mac Pro has a Linux. Mac Linux operating systems, CentOS, and Raspberry Pi OS. Once you know this, and you may know others, right? My laptop is a MacBook, so that I can bring. This is my terminal. I can get my terminal also, new terminal from here. Then I have different background, right? The other terminal, doesn't matter which one that you want to use, right? As I said, this is the Linux running on your MacBook. So as I said, if you say PS, processor states, then this guy showed that much. But Linux, real Linux, our Raspberry Pi can show more. If you want to do sudo PS so that see more, then you can see a lot more. These are the processor running, right? Remember that I said Linux is still running. These many processes are running. While I'm not doing much, right? They're all doing. Where is my command that I issued? Here. That's what I did, right? But on my laptop, the Linux, these many processes are running. That's what I want to do, for example, there. Okay? Remember this? Let's skip. Okay, Raspberry Pi OS. Raspberry Pi OS, formerly known Raspbian, but they changed the name. It doesn't sound... anyway, but that is the Raspberry Pi OS now. Officially, you need to call Raspberry Pi OS rather than Raspbian. It's a Linux-based operating system optimized for the Raspberry Pi hardware. But this is nothing but Debian. Where is it? Doesn't say here. Okay. So as a students, you can do so much things on this Raspberry Pi. One of the beauty is that this Raspberry Pi, for example, all the operating systems where here SD card. SD card. This SD card contains everything about this SD card. About your operating systems. Not only that, this Raspberry Pi, you can use other external USB sticks. Okay? Not in simple way, but do some Linux command. You will learn it. Key features of a Raspberry Pi OS. Raspberry Pi is called RPI in short. So R for Raspberry, Pi is Pi. Raspberry Pi is Debian based. That is a lightweight and efficient. Lightweight, which means it is not a heavyweight. It's not real full features. The most powerful features there. If you need, you can install further and further to make it stronger. Pre-installed software. This RPI OS pre-installed, already installed. When you receive this Raspberry Pi kit that I will provide you next week, so one small box, okay, like a pizza box. So I need to bring about 15 pizza box next week on my shoulder. I do not want to carry them every day, every Monday. So I want to distribute one to each students, one day only next Monday. So if you do not come, then you need to travel to Dobbs Ferry and talk to the department secretary and check it out, okay? All the online students, you also need to go to the Dobbs Ferry. Unless you are far away, at least 100 miles away, then department may be able to send the device to you, mail. Other than that, you guys need to check it out personally, individually. And that way it is quickly that you can get it. Do not ask, for example, hey, professor, I do not have my Raspberry Pi on my hand. Can you extend my homework assignments longer and longer and longer? From my experience, it goes even 2 months after the semester began. So almost toward the end of the semester, some students says, oh, I didn't receive my Raspberry Pi. I cannot do my homeworks. We already had 7 homeworks, 8 homeworks, almost done. Don't excuse, okay? I strongly ask you to pick up your Raspberry Pi within a week. So you better go to the Dobbs Ferry campus directly so that you can get it quickly. Okay, so homework assignments, I'm not going to give it to you today. The first homework assignment about this Linux will be next week after you receive. So first homework assignment is the installation completion. So complete your installations and make sure your Raspberry Pi runs and it's ready for all of us go forward. Your question? Thank you. That's what I thought. So only I'm worrying about the online students. I know many online students are local here also. So you can, at your free time, you can, on your way home from, for example, city to your home, Putnam County, then you can stop over the Dobbs Ferry and pick one for you so that you yourself ready. When you receive that kit, it has a Raspberry Pi and it has that SD card. That SD card contained already Raspberry Pi OS. That's what I mean by here. pre-installed software. Should you always use that pre-installed software that is installed on your SD card only? No, you can use any SD card. You can install it. I know you guys already watched the video the last week that I posted. There I explained if you have your own new SD card, then you can install it. That is a very nice graphical user interface installer. We call that imager, right? Raspberry Pi imager there. So you can use that software to make your image, Raspberry Pi OS image, installed on your SD card. Once you have that SD card, then you don't need to use that Raspberry Pi imager software. You simply plug that into your Raspberry Pi device. Do not, I'm going to stress one more time. When you receive your Raspberry Pi kit, do not do anything but simply that SD card into that Raspberry Pi and turn on. That much simple, okay? I know some students, I do not really blame that students. That students is, oh, let me try to do something on this Raspberry Pi. Good try, right? But your Raspberry Pi SD card may be corrupted. If it is corrupted, you should buy it. Don't ask me to provide. Right? We do not have SD card. And also, from this semester, the department decided to collect. You need to return your Raspberry Pi at the end of this semester. That's what the department decided. But I tried not to, but because the department decided it. Why? Because that Raspberry Pi, that kit itself, $150. How many we purchased in this semester? We have 41 enrollment as of yesterday. I'm not sure, there may be a couple of more students. Then 40 times 150. How much? $6,000. Right? I know compared to your tuition, $6,000 is not. But your tuition is not something that directly comes into the department, right? Department does not have money, actually. The university has money. So who is handling that money? University administrator. We faculty, we are just like you, okay? But anyway, so unlikely the previous, the Linux class, from this class, you guys need to return, okay? I explained that. I have another, so I need to, okay. GUI is possible, but we don't do much about using GUI. And customization, that's part of those. Community supports. And also we are going to do a lot of network. Okay. Another thing that I would say, reason that we need to have our own the Wi-Fi router, so that we have a loop back network packets. We're going to set up the software router on your Raspberry Pi, and we need to block some of the network packets. We open the network packets, some of the applications, then you can block it or you can open it. That type of things needs to be practiced in this semester. on our Linux class. To do all of these things, we cannot link to our enterprise, the university level Wi-Fi router. We need to have our own Wi-Fi router. In that way, we can handle the network also. Okay, that is more important. That is more the technical, the reason that we need to set up our own. For the same reason, we cannot do, for example, the VirtualBox running on your laptop, and laptop goes to enterprise Wi-Fi. Our own server network needs to be installed. That is real practice, not within virtual operating systems. Okay, so Linux is real. This is the example of why you guys need to learn Linux. Linux and unmanned vehicle. You know the one unmanned vehicles? Not in New York City, but if you go to Los Angeles, San Francisco, and what other cities? Maybe Phoenix, right? Yeah, those are three big cities. They're big cities. It's not a real small town. San Francisco, Los Angeles, and Phoenix. The sample big cities. They run a Waymo. Have you guys seen the Waymo? Right. If you are in Los Angeles, for example, then there's one car. It has many cameras. On top, there is a LiDAR cameras spinning. It runs the city streets. You can see the Waymo taxi so often. Then there is no one in that car, right? It's very similar to Tesla, but the big difference between Tesla and Waymo is that Waymo, if you are a Waymo passengers, then you cannot sit on the driver seats. Driver seats is prohibited. On the other hand, the Tesla, if you are, man is in the Tesla, then at least one person should sit on the driver seat, right? That is a Tesla. Waymo is operated by Google. Tesla is a Tesla, right? Difference between the two: unmanned vehicle. Real unmanned vehicle is a Waymo. Tesla is autonomous vehicle, right? So Linux is running. So this slide shows you where the Linux runs. There are so many Linux operating systems running on, which means there are so many microcontrollers embedded in that Waymo. One of those here, sensor, LiDAR, camera, radar. Each one of these has microcontroller, like a Raspberry Pi. In this case, 3 Raspberry Pi on that sensor. And then there is a driver Linux-based sensor driving enabled. And then there is another Linux runs for the perception using machine learning interface. Another system's planning and decisions for that Waymo. Therefore, if Waymo taxi is called, then Waymo needs to automatically understand it and then reach it to the customer and pick that person. Only pre-registered customers can call Waymo right now. Why? Because it should be verified that the caller is a real human. You see, there is a possibility that software may call Waymo. Waymo reaches that the position and that location, no one's there, because there is a software calling, right? That's possible in Waymo. So they need to pre-verify. You guys, if you want to use Waymo in Los Angeles, you have to register yourself first and verify it. Hey, I'm a real person. So when you call, for example, LA airport, hey, come Waymo. Then Waymo comes to you because you are real. You guys all already experienced that there is lots of non-human responders, right? If you call some call center, not always a human can receive your call. There is a robots. So you need to check when you need some help. So then you need to call the help desk. Then you need to first check, are you a robot? Then if it's a robot, then the robot may say, hey, I'm, for example, AI robot. I want to help you, but that robots usually doesn't want to switch to human representatives. I have that experience a lot. When I call some entities, and that guy said, hey, oh yeah, wait a minute, I'm going to switch you to somebody who handle. Then somebody is robots. So I talk to that guy, cannot handle my cases. So can I talk to real representatives? Then that robot says, I cannot understand you. I can help you. So that happens. So this Waymo may be called by robots, right? So Waymo needs to verify that it's a real human. Human passenger only need Waymo taxi, not software, not robots. There's lots of interesting hacking models possible. If you are in LA, then you may be able to test to hack Waymo, okay, by software, not real you. Okay. If you see Waymo only here in this case, then Waymo processes massive sensor data. So each sensor, there is a Raspberry Pi like microcontroller. Waymo historically built on real operating system 2. So real means real-time operating systems. Linux native, widely used in robotics and autonomous systems. Waymo uses a real-time Linux kernel. What is a kernel? Kernel is a real core base software packages that is called the kernels. Waymo vehicle uses a Linux in system style service supervisions, process restarts, resource limits, secure logging, auditing, user and group permissions, mandatory access controls, container sandboxing, secure boot chains. Access control, for example, we call that AC. Access control, there are quite a few different models of access control. One of them is a mandatory. Okay, that is a mandatory access control. Your Linux has already well established access control mechanism, but that access control most likely mandatory access control, not discretionary access control. By mandatory access control means you have an object and objects, okay? Object and objects. Objects has also some rank, some different levels of securities. Subject likewise. So for example, subject has top secret clearance, confidential clearance, non-classified clearance, that type of different levels of securities. Likewise, object has that. This is a top secret documents. This is a top secret object. This is a secret object or secret documents. This is a confidential documents, confidential software. This is a confidential sensors. So top secret clearance can do the top secret objects and also all the lower levels. Confidential security clearance guys, subjects cannot do anything above confidentials. That guy can do confidential or below. That type of things is a mandatory access controls. That happens in the Linux operating systems. Okay, so when you create a file in Linux, the file as you create on your, for example, laptop, then you can create a homework assignments one. That is a file. Sometimes you can create a Word file or PowerPoint files or Excel files, whatever files that you, or plain text files. As you create file, so far, you don't really care that what is the level of that documents. Is it secret documents? Is it open to a specific user? Who owns these documents? Who can access these documents? If that person accesses this document, is these documents allow that person to edit, revise, or simply only reading? Is it allow that person to copy? Allow that person to delete? All such things can be defined. That is mandatory access controls. That is possible in Linux that you will have. Okay. How to get Raspberry Pi OS. Okay, so let's see. I'm going to close this. You don't need this. Okay, you don't need this. And I have, oops. Oh no. Smaller. Okay. two things that I want to show to you before we close today's lecture. Okay, this first. If you want to check out, checking out this Raspberry Pi is not mandatory. If you have your Raspberry Pi, your own Raspberry Pi, that's perfect. You don't need to check out. Check out and return agreement. Department of Math and Computer Science Department, more specifically cybersecurity program, because this course is run by a cybersecurity program. I wanted to collect either you are on MTA or DLA. So you guys right now with me, you are in MTA section. Online students, DLA. This is already semester 2026. I wanted to put here your full name, your student ID, university email address. It's not necessarily university, but email address, right? I would change this. Email address and phone number. And Raspberry Kit interface, the information. This is a Raspberry 5. So I want you to click here. Serial number. Serial number will be given to you when you see the box. We didn't put their serial number yet. I think right now Department Secretary probably put there. It is start with Linux -2026 spring number sign pound followed by number from 01 to 40 some. This is a given. When you receive your box, then you will see that. So I want you to enter there only number. And then SD card, you may be able to see what it is. I think that is 128. None of this. I guess 128 gigabytes. So you need to put here 128 gigabytes. And the key content there, Raspberry Pi device, micro SD card, and power supply, power cable. It's not power supply, power cable. Power, should say power cable. And HDMI cables. Power cable, let me show this to you. This is a power cable. This. At one side, there is a wall, two prong, not three prong. Two. And the other side, USB-C type. So USB-C type goes into your Raspberry Pi. This is a power line, white cable, power line cables. And this is black ones. This is HDMI. At one side, there's a regular HDMI. At another side, there is a micro HDMI. Micro. This is small. This Raspberry Pi has two HDMI ports. Okay, so you can use, and the other maybe another. If you do not, excuse me, if you do not have any extra monitor like this, but you have a TV, right, at home. TV has a HDMI port. You can use that TV HDMI port. If you want to show one for yourself, the other one for your parents, the other cables to your parents' TV sets. This cannot go into your laptop. Well, HDMI cables itself can go in, but it doesn't display. Your laptop monitor doesn't display anything from outside. You see that, right? This terminal, your laptop, this monitor always comes from your laptop processor, right? Not from outside. Anything that you can plug your HDMI, that is outlets. It go out, right? Go out from your laptop, not coming into your laptop to display, to use your laptop monitor. I wish we could, right? We need to ask the laptop company, hey, why your laptop monitor only display something from your laptop computer? Why not we use it from outside? If it works that way, then it's so nice, right? Would it be possible? Of course it is possible. Is it hard to modify? No. Simple modifications as a manufacturer, for example, if it is a Apple company or a Samsung company, they can make it quickly, a little bit of a tweak, right? The dual ports. So sometimes it can display from inside or from outside. How nice it is, right? Are you willing to pay $50 more? Of course you can do, right? To tweak that, your laptop monitor manufacturer cost more than $50? I don't think so. Maybe $5. But they don't do that, right? Why? No one need it, right? Except our students in this class. Because we have this Raspberry Pi, I want to display this on my laptop terminals. But we cannot. Then should we bring this monitor, independent monitor, all the time? One time. Maybe you can do that at home. Or you can borrow my monitor here. I'm not going to bring this every class in this semester. I'm going to bring this first couple of classes. Then how I can show this on my laptop so that you can see on the screens. How? Again, we have our own Wi-Fi router. So this guy can go into that Wi-Fi router and loop back to my laptop and display. Would it be interesting to you? You want to make it? Yes, you can. You will learn it, right? This technical barrier will be resolved in the next few weeks. Okay, these things needs to be returned, definitely. But when you see the kit, you can see more. Case and micro SD card adapter and other accessories. I do not remember what others. So these three things must be returned. 4 things. These HDMI cables will be provided 2 of those. Okay? But at least 1 needs to be returned. The other you can keep it if you want. And student acknowledgement and agreement. Here, I received a complete Raspberry Pi kit. You can see that. I will give you unpacked box. But from next semester, maybe some students may receive the one used by you, and we want to refill with the refill with the brand new. So some students may receive second hand, some students may receive brand new. Raspberry Pi kit, so department properties, and I agree to take responsible care of the device and accessories, not permitted to modify, sell, or transfer ownership of the kit, return all the components, particularly Raspberry Pi, SD card, cable, specify return date, and then provide my own. So you can, in order to use this, your own monitor, your own mouse, your own keyboard, you can use that all the time, or you can one time at least, as I would do. And once your laptop connects to your Raspberry Pi, then you can use your laptop keyboard, laptop mouse, laptop monitor. Very, very handy. I'll show that to you in a minute. And then I understand the failure to return the kits or returning it damaged beyond the normal wear, replacement to charge, a hold, or academic record, or any other action according to the university policies. So this, if it is not intentional, I would not, okay? So if it is not intentional, then you'll be okay. Also, department chair agreed to replace if there are some damages, okay? It's not. So return is important. If you do not return, then charge. If you return but damages, maybe okay. All right. So that I can say, hey, this is damaged. So can we reorder? Then we can order. But if there's no return, then hey, there's a missing. Then they blame me. Okay, this is the documents that you need to fill when you check out. So I'm going to make this next week. When you come, you fill this out, and then you can get the kits from me directly. For online students, I am going to put this on the Blackboard, so you can fill this out and take this to the department secretary. I'll put that on the online class as well. Okay, the other one. I'm going to show this to you. There is I want you to pass this around. Take one each. It is called the Mercy University Linux Club. This is not mandatory. So we want to set up a class. We had already a class from last semester. This is possible for the in-person and online class students, both possible. So by name club, you may see what it would be, right? But because this is a Linux club, so you guys set up the social network among you. We have another group of students who already know the Linux from the last semester. And this semester, the students, we can put them together as one body. So this is extra curricular curriculum. So if you want to join, I want you to fill out on the third page, right? There is a Mercy Cyber Linux Club application forms, your name, student ID, email, phone number, major, year of study, and interest. Check all of your the topic of your interest and experience with the Linux. Many of you say beginner, just starting. Availability for meetings, weekdays, weekends, others. And you can say something here and sign and date and give it to me. Then I will collect all of this. And the first meeting will be announced. It could be, I think it could be Zoom because the students already passed this Linux class, but they are in the same Linux club. So you guys and them needs to meet. You guys can do maybe in-person meeting once a semester or twice. We can plan that. Last semester, the first meetings, so the department supports financially. So department doesn't provide you meal, but pizza. Okay. So we can order some pizzas and sodas and talk. That's what we want to do. Okay. So if you are interested in immediately, you can fill that out. You can give it to me, or you can give it to me next week, but not towards the end of this semester. Okay. If you want to join the Linux Club, do it quick so that we can plan early. Okay, this is the thing that I want to share with you. 2 documents that you already had, right? All right, so what is next? All right. And then even if I told you verbally, so what is the application that you can, for example, communicate between your Raspberry Pi and your laptop monitor? That is, the software is called RealVNC. RealVNC Connect app. Let's see, RealVNC. No, not this one. If you have this, then you have to remove this. Let's see, can I not only remove, can I quit this VNC. The one that we really want is this VNC Viewer. Okay, so I want to show that to you. VNC. Okay. Anyway, you guys need to do this. Go to VNC Viewer download, not the VNC download. If you see VNC download, then that is that is a VNC server is running, and also you have to pay monthly. That is very, very expensive. I don't want you to waste money. Don't do that. Don't go that way. We simply use it as a viewer. So there's a lightweight the products of that RealVNC the software. It's called the VNC Viewer download. So keyword, search keyword here is the VNC Viewer download. What is this? VNC, you call that VNC VNC Viewer download. What happens? Currently, there's AI. Why? I don't like AI. Well, I like AI, but sometimes it interrupted me. Here, download viewer by RealVNC. This is what download VNC viewer by RealVNC. Yeah, this is, what is it? VNC viewer download. VNC viewer is a remote. This is different. Two different providers, right? So which one that I need to use? Okay, go to here. That is a real company. The other one is, yeah, this is the one. So don't try to do this VNC viewer server. Do this VNC viewer. Okay, VNC viewer. Make sure that is a VNC viewer, not something else. And then download the VNC, RealVNC Viewer according to your platform, either Windows, Mac OS, Linux. So in my case, Mac OS. If you download, then you can see that. So for example, when I see the download, then I have here already, right? VNC Viewer. VNC. I already had here. So this is the second one, right? So have within parentheses there's a number one. So you can click this, double click, and then install it. Then you will see this VNC Viewer app. Don't try to use the other here. VNC connector setup. This VNC RealVNC connector. If you have that once, so I want to remove this. Then it asks me to register and pay. It asks me enter my credit cards. So don't do that, okay? We don't use that much. We use it simply from Raspberry Pi to our laptop monitor. That is enough for us. In that case, you can simply use VNC Viewer. I'm going to trash this. So VNC Viewer 7.15.1. Install it. Then you will have this VNC Viewer. Once you have this, then you can do double click this. I already set up. So I think this is a Manhattan 425. But right now that our Raspberry Pi, Wi-Fi router is not up and running, so I cannot connect, but we can do this next week, from next week. You can set up something about the Kelly. This is about the Kelly and many others, right? So using this VNC viewers. Okay, I think we So this is something that you have to do. Okay. RealVNC Viewer, no, not only for Mac OS, but it could be Windows. So this is important. RealVNC Viewer. So you need to download it. Then it has tell you thank you for downloading, and you can go from there. Okay. This is everything that I prepared for today. Any question?